All right, scenario number 2. This is page 194 of the notes. 84% of a simple random sample, so we have a simple random sample of 125 nurses express job satisfaction working to 7 a.m. to 3 p.m. shifts, while 72% of the simple random sample of 150 nurses express satisfaction working from the 11 p.m. to the 7 a.m. shift. Establish a 90% confidence interval for the difference. So P1 equals P2, and we have a difference. So P1, the true population proportion of satisfied nurses in the daytime shift. P2 is the true population proportion of those in the nighttime shift. And basically, the 7 to 3 p.m., this is daytime, and 11 to 7, I'm calling night. So this is day, and this is night. And I could have used hours as opposed to saying days and nights, but I thought it'd be easier to do it this way. Random samples were given for both of them, so that was nice. And it's reasonable to assume that one shift job satisfaction does not impact the others. So that means we have 2 independent random samples. And we need to check the sample size to make sure it's less than 10%. So 125 divided by 0.1 is 1250. Reasonable assume 1,250 nurses working daytime shifts. I don't know if that's reasonable or not. That seems like a lot, but that's what we have here. Must be a huge staff, but maybe it's multiple hospitals. 150 divided by 0.1 is 1,500. Reasonable assume that more than 1,500 work the nighttime shifts. Once again, that is a lot of people, but we'll have to assume that that's true. In P, let's see, we had NP is 105. Well, where did that come from? Well, because we had 84%, so 0.84 times 125. So that's 105. So this came from 0.84. Because remember, 80, so this is 125 times the 0.84. So 105 expressed said that they were satisfied. This is going to be 125 times 0.16. All right. And 125 times 0.16 is 20. This is where it's very easy to get a decimal response. And please note, these X's, when you put them in the calculator, must be whole numbers. And we do the same thing over here. We had 150 times the 72, 150 times 0.72 equals 108. And then here we had 150 times 0.28 is 42. So in both cases, this sample, both of these were greater than 10. These were greater than 10. Both samples are large enough to use the normal approximation. Well, they want us to construct a 90% confidence interval. So let's go ahead and calculate our Z star. So Z star is going to equal second vars inverse norm, parentheses 1 minus 0.90, close parentheses divided by 2, mean is 0, standard deviation 1. And we get 1.645. So our first P hat 1 was 84%. P hat 2 is 72%, plus or minus 1.645. This is P hat 1. This is P hat 2, which is 1 minus 0.84. This is P hat 2, or excuse me, Q hat 1. P hat 1 and Q hat 1. This is P hat 2, and this is Q hat 2. This is our 72%. This is 1 minus 0.28. And here's N1, and this is N2. So let's go ahead and run this thing really quickly. Stat test 2 proportion Z interval, letter B, and we had an X value. And remember, our X and N's must always be whole numbers. If they're not, you're going to have to round them. So X was 105 and N was 125. This was X was 108 and N was or N was 150, and we want to do a 90%. And we ended up with not what I'm supposed to end up with. How did that happen? Oh, stat test 2 sample 2 proportion Z interval. Oh, it wasn't X1 is 10, X1 is 105. Not sure how that happened. And we end up with 0.0391 to 0.02009. Now, please remember P1, this was our daytime shift. This is our nighttime shift. Okay. So we are 90% confident the true population proportion difference between nurses satisfied with their job daytime versus nighttime lies within the interval 0.0391, 0.2009. Repeated sampling, we expect this method will capture the true population proportion difference between nurses satisfied with their jobs in daytime versus nighttime 90% of the time. And if we notice, 0 is not in the interval again. So that means it's statistically significant. All right. And because this is positive, we know that daytime must be larger than nighttime. So daytime satisfaction is greater than nighttime satisfaction because we went day minus night. Okay. Because we went time minus nighttime, and it's positive, then we know that the greater percentage of people being happy is in the daytime shift. And we know that this is statistically significant because 0 does not lie within the interval. Okay, thank you.